In figuring out this serpentine wall, one of the first things we're going to do is make a slat structure along the edges of our profile curves. And to save time, I've made the curves existing so you can loft from here. All right, one of the first things to do is the input. And we're going to input the top and the bottom curve. And we're going to label them. So we keep track of this. And we're going to, after labeling them, one of the first things to do is, as we have an inner and outer part of each wall, is we're going to offset. And we're going to start with the top curve. And we're going to create a number for the width of our offset. And we're actually going to call that rail offset. And we'll go ahead and set this manually right now to 2. And we're going to do that on both sides, as you'll shortly see. And you see how that goes out 2 inches. And now we're also going to make the offset for the slat. And that's taking that previous offset, and it's going to be uniquely for this slat. Depth. And we're going to set that to a 1 by piece, so 0.75. We're going to put that down here. Okay, so now, after getting that done, we're ready to divide our curve and get everything started so we can start seeing where we're going to put our slats. And for our curve division, what we're going to do is we're going to go ahead and make a number slider. And we'll make it an integer. And we're going to make the maximum, the minimum at 30 and the maximum at 100. And as you see the wall, you see these dimensions and why we've chosen them. And one thing I'm going to look at, and I'll show you, is that the height of this wall currently is at 8 feet. You see on the grid. So if you look at it from plan, you start to see that it's about 1 foot between slats. So we probably want a little bit more to get the density of the serpentine wall surface. Okay, so now we have the division, and we're actually going to make one division for the inner slat, one for the outer slat. And we're going to hook up that curve. And now we have the 2 sides, and we're going to go ahead and copy these, not the set dimensions, like the slat and the rail, but the offsets and the divisions. And we're going to do that for the bottom curve. We're going to turn off the solver so we can do this pretty simply. We just have to change one element. Turn the solver on. You see we've got all the sides. Okay, so now we want to go ahead and make lines from the top to the bottom. These are constructed lines. So we're going to make one for the inner and one for the outer. Connect these with A and B. And we connect these with A and B as well. And now we want to loft these, but to loft we need to merge the data forms. And we will need to simplify and graft each one. You can already start to see the slat. So these are, right now it's just the lofting. You'll see the form as we get into the visualization. Alright, so now we have the outer of our rail, the outer slat. Now let's work on getting the inner, and I'll disable the solver as some things have to be hooked up. And the only thing I'm copying is going to be the operational code, not the main dimensions. And one of the things that's going to, key things that are going to change is basically the origin. And that's going to be these main curves that are offset. The issue is the direction in which it's offset. We're going to change the expression to do that. And we're going to go into the other direction, so we're going to offset negative times the rail offset on both of these on the other side. Alright, so let's take a look at that. And you see now that we have both sides of our wall, we'll have the slats there. And just to see a full visualization, I'm going to do like a simple offset so you can see the 3D, and we're going to refine that later. So we have our two sets of lofts, and one thing we can easily do is actually offset the surface, and from that, simple offset, and we're going to go ahead and set the offset is going to be the width of our slats. So that's going to be a good number. And we're going to do that actually divided by 2. And our width is actually going to be 2 inches. So we're going to make these equal to 1 inch because it's going to 1 inch on both sides. And the surfaces are, we're going to do this for 2 surfaces, one for the inner, one for the outer. You can see how it's starting to pan out. And so the final thing to really do is, as in the loft, is get the edges and then get the edges of each of the surfaces. And right now we can hide the original as we can offset on both sides. And we're going to do this for inner and the outer by using an expression x times -1. X times -1. And both of the central lofts, we can go ahead and hide these as well, the original curves. These being, of course, also needing to be done with our merges, so you don't see that geometry. Alright, so the next thing we're doing is getting the edges of the surface so we can connect both sides of the slats. We're going to go ahead and get our edges from our B-rep, which is our surface, and we'll be taking it from the loft, from the loft offsets. We'll get one from both sides. And you see pretty much one is inner, one is outer. And we do the same thing we did with the previous merge. We're going to go and simplify and graft, graft and simplify. And our top set of edges is going to merge with this, and we're going to go ahead and loft it. And now you see our slat. And we're going to do the same thing above, just to simplify. I'm just going to copy it. I'm going to disable the solver. Sometimes I copy it so we can simplify the time, and we just change those plugins here, enable the solver. And the last thing I want to do, so you can see the lofted curves, inner and outer, is I'll go ahead and down here make a loft to the inner offset of the rail above. And this also, of course, is one of the things that we're going to merge to get. So merging is very necessary to loft to clean up the data form. So that's from the first outer, and we're going to turn off the solver because we have to do the cleanup again. And graft and simplify, graft and simplify. And we're going to do the same operations for the bottom, and we'll do that. Replace that one. We're lofting the top and the bottom rails as well. Okay, so now you see the rails. Now you see the slats. And yeah, you've pretty much seen the base of how the serpentine wall starts. You see how this code was to pretty much, it was easy to duplicate what's being done for one. And in the next session, we'll get how to make this more precise in our visualization, and then on to how to refine the model and get it ready so it can be constructed via export.